All right, so so this is going to be your directions on all of them. It's going to just say solve. Eventually. There we go. All right. So I start a whole new page because it's going to I'm going to need way more space than just the little bit that was at the bottom. So we're going to go through all the steps. I'm not really going to be able to label them necessarily like first, second, third, things like that, but we're going to try. So we have that x plus 1 equals 4 over x plus 1. All right, so anything that is written where it doesn't look like a fraction is still a fraction. All right? Even though it doesn't look like it, these all have denominators of 1. Okay. So when you are trying to fraction bust later, you have to look at each of those denominators or each of those terms as well. All right, so this has a binomial denominator. All right? When you're thinking about your LCD, it's just going to be that denominator of x plus 1. I don't need to write the ones from the first two, but you have to consider that those are still fractions. So I didn't really have to do anything with step 1 because I'm not factoring anything. It's already done for me. My restriction or extraneous solution is still going to be when is this denominator going to be 0, because that's something that's still not allowed. So when you look at your common denominator, all the factors, you still have to set that equal to 0 and say x is not allowed to be negative 1. So think about your extraneous solutions exactly like restrictions, all right? Everything you see that is a restriction has to go there in that ES, extraneous solution section. So now you're pretty much just going to be down to one of the other steps where you're fraction busting, right? You have to multiply every single one of these terms by that denominator. So every single one of those terms has to be multiplied by x plus 1. Your goal is to get rid of the fraction that's already there, but you can't just get rid of a fraction without considering keeping the equation balanced. So whatever you do to one term has to be done to all terms to keep the equation balanced. If you do it right, those are going to cancel and you will no longer have a denominator. However, you still have to now multiply and combine all of the terms with what's happening over here on this side. So you have to do a lot of distribution. So you're going to break up the first set of parentheses by distributing that x to both of the terms. And you're going to get x squared plus x. And then you're going to have to do the same thing. Whatever number was here, it has to be distributed. You're going to get another x plus 1. And then on the other side of the equal sign, when the x plus 1 fraction busts and it cancels, you don't have anything left. All right, so there's no denominators, there's nothing to multiply by, it's just done. Okay. But now you have to try to think about, like, what is this going to look like when I start combining my like terms? Right? You have something squared, and you have something to the first power, and then you have constants. All right, so instead of separating variables and constants like you normally do, this is going to end up being a quadratic I'm going to have to solve. So I want to try to recognize when that's going to happen when I have something that is a squared term. Because when that happens, instead of separating variables and constants, you got to move them all over to the same side. And so this really should be an x squared plus 2x. And if I move forward to the other side and subtract it from 1, I get minus 3 equals 0. You still have to show that it's still an equation. It's still equal to nothing when I moved that term over. But now you have to factor this. So now again, all of your module 6 factoring skills have to come into play. All right, a is equal to 1, so I can look at the product that's negative 3 and a sum of positive 2. Right. So I'm going to use x plus 3 and x minus 1. And again, just like we did before, you don't have to actually set these both equal to 0 like on your paper. You just have to do it mentally. All right, so when x is 1 or -3, those would be the solutions or the values that would make my original equation true. And the only thing that you have to do before you box your answers is you just have to double check that these two, that neither of them are one of your throwaways, one of the ones that were a restriction. So I'm restricted, I can't use -1, but that's not one of the values that I came up with. So both of these would be answers. They're both fair game, officially going to work. So you always have to double check if some of these answers you come up with are one of your restrictions, and if not, keep it all. If it is, throw it away, and it's not one of your answers. That's pretty much going to be your process most of the time. All right. So it does take a little bit just because you have to be very careful. But for today, that's kind of a little bit what we're going to be doing. All right, so we're going to do a couple. All right, so you've got 3x minus a half minus 1 over x. All right, so now there's more denominators going on here. So same thing, least common denominator. All right, so now I need both a 2 and an x. All right, I need to look at all the number portions. These are still monomial factors. And then when I'm looking at my extraneous solutions, there's never going to be a time when this denominator of 2 will be a 0. So remember we talked about before with restrictions, if it's a number, it stays a number. If it's a variable, the only thing I can't use would be when x is 0. So that's the only answer I'm not allowed to have. Everything else is good to go. All right, so multiply every single term by that 2x. Yes, sir. Your common denominator, I need to have a factor of 2 and a factor of x, otherwise I can't make these denominators the same. All right, so the thing with this is that you have to multiply everything still. All right, that's why I'm still showing you that I'm still multiplying whatever's on the right-hand side of this fraction. Even though it's a 0, you're still multiplying by that common denominator. Right? On some of these, you're going to be canceling out part of the factors, and some of them are going to be left. So, for example, when I multiply this together, I'm going to end up with a 6x squared. But on the next term, the 2 cancels with the 2, and I'm just left with the factor of x. So sometimes when you have multiple factors, some of them are going to stay there, but you still have to distribute. So like -1 times the x that's left is -x. So when you shift over to the third term, this x cancels with that x, but again, the 2 is what's left. So -1 times 2. And 0 times anything is just 0. Right? And so now you have another quadratic. The nice thing about this quadratic is that there's no like terms or anything to start simplifying. I can just start factoring. Right? And however you like to factor is completely up to you. But I'm faster at an area box. So I can look for factors of -12x squared that add up to be a -x. So probably a -4x and a 3x. And so that works for me. Again, it doesn't matter which order you put them in. All right. Usually you would flip-flop those so that way the 3 and the 6 are on the same line, but it doesn't matter. All right. And you're still going to get the same 2 factors. So you have 3x minus 2 times a 2x plus 1. And those are the 2 factors that I need. And again, if you can solve these 2-step equations in your head, go ahead and do it. Right? You don't need to show it unless you just need to for making sure that you don't get it wrong. And again, before I box my answers, I just got to make sure that neither of these two are my restriction, and I'm done. Yeah.
I have a question.
Yes.
So instead of putting in the box, I just look for two numbers that multiply to negative 12x and add them up to negative x. And I got x minus 4 and x plus 3. Why is mine different from yours? Did I make a mistake or is that not the right process? Or?
So you're saying you got this?
I can see.
Yep.
Yeah.
All right, so you can't just use the two factors that you have in something where a is not equal to 1. When a is not equal to 1, if I were to multiply this through x, and x is not a 6x. So you have to use those two factors and either put them in an area box or do factoring by grouping, one or the other. So so if you look at the two options of factoring that we have, all right, you can either, when a is equal to 1, you're able to just use those two values because the first two terms when you multiply are just going to be exactly like what you have, all right?